everybody. I'm Shipra, a final year graduate student at Indian Institute of Technology, Kharagpur. I'm going to present my research work that I have been done in a partial fulfillment of my degree, my master degree. And the title is the application of a Markov chain and entropy function for cyclicity analysis of a lithostratigraphic sequence. And the area is a Kolhan basin, Jharkhand. The main objective of my research work is basically first to recognize the various lithofacies present in the study area. Then I evaluated statistically the cyclic character present by the Markov chain analysis, and based on that I have done the upward facies transition that is present in the area, research area. Then using an entropy analysis, entropy function, I actually calculated the broad energy regime of the region and degree of ordering, and the last is to recognize the broad depositional environment of the basin. The study area is the main basin is the main study area is a Chaibasa Namundi basin, and the length is a 60 kilometer, and its width is 10 to 12 kilometer, extending from a Chaibasa in the north to Namundi in the south. The strike is north-northwest and south-southeast, and dip is a very gentle dip of 5 to 10 degrees centigrade. It's basically it's a meta-sedimentary rock rise unconformably over a Sengum granite. It composed of a cell limestone and a shell, and there's a unconformity between the Sengum granite, which is in the east, and in the west zone it is like partially connected with in touch with a folded and thrusted fault of iron ore group, basically the whole sedimentary rock it has a very gentle tectonic deformation and a very low grade of a metamorphism. Basically, like a statistical technique like Markov chain and entropy analysis has been used by like various researchers, and it has proved that it is used to reveal the cyclic property. Now in my research area, there's an absence of a fossil assemblage, land vegetation, and the paucity of exposure, so it's like difficult to interpret the broad depositional environment of the basin. So basically in the study area Chaibasa Namundi basin, it has been observed that there's a growth lithological asymmetry present between the various lithofacies, and there's a marked lithological asymmetry basically between the sandstone. The thickness is very large. So to prove the cyclic arrangements and to depositional environment, I have done the analysis. Now, basically in my study, the cyclicity I have founded is basically the order of a sequence is only. I ignore the thickness because I have taken each bed as a logical unit and examining the cyclicity based on that. Now data which is used to structure for the Markov chain is first is identification of a lithofacies. For this I have done field work has been done, and lithofacies has been analyzed based on the field description, its petrographic investigation, and a vertical packaging. Now we developed the vertical sequence profile at the 17 different areas, and based on that the 6 lithofacies has been identified. Their description is first is a granular lag facies, which is characterized by the massive ungraded and fine matrix supported conglomerate. It's basically a laterally impersistent, which is mature to submature. And the second is GST. It's moderately well sorted. It has a large size as compared to other, and and you find planar cross stratification is common in this. Second is a seed sandstone, which is like a seed of subarcose and a quasi-arenite, and sometimes intercladed with a thin laminated siltstone. And the fourth is a PLST. It's defined by amalgamated well-sorted subarcose arenite and with a moderate to high-grade matrix. And RST is defined. RST is a ripple sandstone. It's a 5th lithofacies, and is defined by the predominance of the package of ripple sandstone with the presence of symmetrical and asymmetrical ripples. And 5th is a TLSD, is a thin laminated sandstone defined by the rhythmic alternation of a sandstone on a cell unit with a sandy layer thicker than the cell. Now, based on our vertical sequence profile, I have calculated the transition frequency matrix. It's basically a two-dimensional matrix which note the number of transition for faces I to faces C. Row define the faces I and columns of faces J. And since I'm using a Markov chain which has a memoryless property, so all the 17 sequences has been combined together without the loss of information. And basically, I calculated first the transition frequency matrix, and based on that, there are other matrices has been calculated, which are like a upward transition probability matrix, which is basically it gives the probability of transition from faces I to faces J in an upward direction. The similar is a downward transition probability matrix, which gives the probability of transition from two different faces in a downward direction. These are the matrices which is used to calculate for the analysis, and it's an independent random trial matrix. It's basically we are assume that the whole depositional process is random, and from where it's like independent. One face's deposition is independent of other, and from there this is the formula which we have used. And the difference matrix it gives the those lithofaces which has a probability of transition greater than if the deposition is a random. And expected frequency matrix is basically like the average transition between the two faces. So this is the formula for entropy analysis which have like used. These two type of entropies which is calculated. These are one is a E post and second is a like E pre deposition. It gives the order of a randomness or like order of a degree of a associated with the faces I, with its like faces J which are successor of it or deposited above it. So now to test the significance of my analysis, I have done like chi-square test, and from these tests I have find that with a significance level of 0.5, this computed value is less. So like the null hypothesis here which shows that it's false. So like it has a non-cyclic deposition pattern. Now, Markov chain analysis. Now to calculate the upward transition frequency matrices, I have combined like a difference matrix and an upward probability transition matrix. And based on the positive value of the difference matrix, which shows the positive value, which shows the like number of faces transition which is like most frequent, and the highest value of a upward probability transition matrix. I have calculated the upward frequency transition in a faces, and from these we have get the finding upward sequences basically. And since from chi-square test we have seen that it's a deposition is my non-Markov process, so all the lineages is non-repetitive in nature. Now from entropy analysis, these are matrices which I get from the entropy analysis, the formula which I said in earlier slides. And from here it has been seen that all the entropies are like larger than 0. So basically like all the faces have been overlined and also overlain by the more than the one state. Now it's been shown from your data that in a GST both entropies are very large. It means that they like influx of the pebbly sandstone is the most random event. For GST and a PLSD, entropy is greater than E post, and like you have been seen that it can be overlined by the more than one different state, and it can be succeeded by only selective states. And the similar, this is standard diagram of the Hattori, 1967 used, and from the like plot of e-post and an e-print, we got the characteristic C type of plot, and from where it is like it shows that it's like mostly very random lithic deposition, like lithological series. And from this graph, which shows the relationship between entropy and depositional environment of lithological sequence, this black dot, this gives the total entropy of the deposition, and it's coming this fifth curve, which shows it's a point of the maximum entropy. Now from my entropy analysis and a Markov chain and from field observation, I have calculated we deduced the sediment flow model. And from there, it's like fluctuating value of entropy suggests that the changing environment and symmetric sequence is related to the sediment bypass, and which is due to the change in our energy regime. Now, we get from upward transition phases diagram, which we developed from the Markov chain analysis. It's so that it's a finding upward non-cyclic sequence. And now, since we have got in a few places the entropy is very large. So absence of a marine feature suggests that this sedimentary deposit are of a fluvial deposit, and variation in a layer thickness in a different sedimentary sequence is offered by unsteady flow in a fluvial regime with a channel within a channel. Now, from the high energy in GLA and GLST, we conclude that these are the high energy deposit environment and the product of a rapid fluvial dactylic deposition. Now, since the GLA and GST is overlain by the shell, which is of a very high thickness, so and from field observation, we have seen that because of the presence of the iron ore thrust here, we conclude that can be one of the possibility that the shallow depth in the basin is because that the basin has a risen against the iron ore fault, and this changes the slope of basin, hence the energy of the flow decreases, and because of the depth reason, the depositional energy changes to a low energy lacustrine and deposited shell away from the basin boundary. So in conclusion, the study area represents the finding upward non-cyclic deposit, and the energy of deposition is changes from a deltaic to lacustrine. These are the references I have used. Thank you for listening.
Okay, thanks very much, Ms. Shipra Sinha. Thank you for your good presentation, Ms. Shipra Sinha. And who would like to ask? Ms. Shipra, would you like to ask? Okay.
What is the significance of this Kolhan basin? Geological significance of this Kolhan basin. Why you have taken up that basin?
Geological significance?
Iron deposits in Kolhan basin? No.
Yeah, no, what? Repeat it?
No, mineralization wise, has it got any significance?
Yeah.
Mineralization wise, has it got any significance? No. No economic mineral deposits in that, isn't it? Yeah. No economic mineral deposits in that.
Sorry, I cannot understand the question.
No economic mineral deposits like iron ore.
Oh, no. I haven't worked in that.
Another thing you told, basin has risen. Basin level has risen.
Yeah.
That is why
basin has against iron ore thrust.
Why it has risen? What was the reason for it? It's a tectonic uplift?
Yeah, it's tectonic uplift.
Or shallowing of the basin because of the sediment dumping?
No, it's because of tectonic. Basically, the slope was very large. So when the sediments deposited, it was it was very rapid deposition because of a very slope. And after a few time, because of a tectonic upliftment, because of presence of iron ore thrust in the west of the region, the basin depth becomes shallow, and because of the shallowness in a basin depth, the flow energy decreases, and that's why we get the shell thickness basically.
Then what is the significance of demarcating 6 lithobases in sandstone?
Yeah, in this we actually we are finding if there is any cyclicity present in this basin, this 6 lithofaces, it's used to because sandstone thickness is very less. So and these are different characteristic of sandstone deposited at a different in a small thicknesses. So we basically wanted to know if if there is like any cyclicity present, because similar basin in different areas like Gondwana and other have a 3 and 4 cyclicities there. So we tried statistical method here to calculate if there is, we can find the similar cyclicity or not.
Okay, who would like to ask? Michelle?